Welcome to all. On behalf of Department of Statistics, Dr. B.R. Ambedkar Open University, normal distribution. Today with us two professors. One is Professor K. Sampath Kumar, HOD and Dean Faculty of Science, Telangana University, Nizamabad. Another professor is Professor N. Raju, HOD and Professor Guru Nanak Institutional Technical Campus, Hyderabad. Today we are going to explain what is the importance of normal distribution, what are the applications of normal distribution, what is the real life applications of normal distribution. So now I am going to hand over the first Professor Dr. Sampath sir.
Today we are discussing normal distribution. This is very important distribution in statistics. Without normal distribution, I think there is no statistics. The statistics importance is increasing day by day because the statistics actually the mathematical formula is established by De Moivre in 1733 and afterwards Gaussian distribution name has come by the Carl Friedrich Gauss. So, the normal distribution function is mainly symmetric distribution. This is almost all similar to bell shape. This normal distribution applied to different estimation theory and different type of calculations in statistics and forecasting.
What is the actual difference between discrete and continuous probable distribution? I think it is a continuous probable distribution.
Yes, normal distribution is a continuous distribution. This is a actually for example, we can take the heights of a some persons. This is a values, numerical values continuously we can show. It is a continuous distribution means the when we construct a curve, it is continuous form of the curve.
Yes, yes sir. In previously students are studied discrete probable distribution like binomial and Poisson distribution. In normal distribution also is a limiting case of binomial distribution as n tends to very large and neither PR nor QR very small. Then Professor Raju sir, please explain in detail what are the normal distribution statistical parameters with applications.
Thank you Ramesh, Dr. Ramesh. So today we are, so eminent person Dr. Sampath sir said what he said is exactly the distribution was a very important distribution. Today we are taking the normal distribution in any field. Every field is having the most important fundamentals. These fundamentals are very related to this normal distribution because we can apply the normal distribution properties wherever it is required. So today normal distribution is one of the important probability distribution in statistical analysis. Whichever field is there, either nowadays in even though machine learning and data science, other parameters, event science, social science, physical science, wherever it is required, this normal distribution applications we can use in our daily life also. That is the most important thing in statistical analysis. Now, normal distribution. So, what is a normal distribution actually? So, now I am going to define the normal distribution. The definition of normal distribution. So, normal distribution is one of the continuous distribution. Okay.
Yes.
So, in terms of normal distribution, in terms of continuous property, continuous distribution, we define the normal distribution. What is the normal distribution actually? A continuous random variable x is said to have a normal distribution with parameters mu and sigma square. If its probability density function, simply it is represented by PDF, is given by f of x is equal to 1 by sigma into root over 2 into pi into e to the power of minus 1 by 2 of x minus mu by sigma whole square. This is the probability density function of the normal distribution. Okay. If we can say any distribution is said to be normal distribution, generally we should satisfy the two properties, especially one is first property is first condition, that is known as a condition. Moreover, before define the normal distribution, we define the parameter range also. So, x lies between minus infinity to plus infinity, mu, one is a parameter mu is also lies between minus infinity to plus infinity. That is why we are saying this is a continuous distribution, and standard deviation and variance sigma square is greater than or equal to greater than 0.
Never be negative, always
Yeah,
zero.
always these are positive. So here we have observed the two parameters here. One is pi, another one is e. So these two are constants. Okay. So we know that pi value is equal to 3.14159. This is the pi value.
That is a mathematical
Constant. These are the constant. The constant value pi is equal to this one, and moreover that exponential value u is equal to 2.71828. Okay. Now what I said earlier also, then this function is bell shaped. So Dr. Sampath said, so normal distribution is behave like a bell shaped. Okay. Why it is a bell shaped? So this is a bell shaped curve with different centers and spreads, depends on two parameters. One is mu, another one is sigma. Based on these two parameters, this normal distribution behave like a bell shaped curve. Okay. So moreover, before that, one more we have to need to check. So whether the given function is already said probability density function. For that, we need to check two conditions. One is probability of, that means p of x function is greater than or equal to 0. Second one is total integral value, that means minus infinity to plus infinity f of x dx value is equal to 1. Then x ranging from minus infinity to plus infinity and mu ranging from minus infinity to plus infinity, and sigma square is greater than 0. Generally, this normal distribution is represented by one notation. Okay. If x follows normal distribution with the parameters, already we know that mu and sigma square are two parameters. Okay. So mean and variance.
Two parameters.
Then two parameters, mean and variance. So then mathematically we can write x follows n of mu comma sigma. What instance n is a normal distribution. So this is the definition of normal distribution. Now I am hand over to Dr. Sampath Kumar sir. He will explain about moment generative function and other that properties.
Yeah, generally when we study the normal distribution, most of the properties we can discuss on normal distribution. In that, one of the thing is moment generating function. So we can take the moment generating function. Generally we can calculate the moment generating function for discrete distributions and at the same time continuous distributions. For particularly if we go for the normal distribution, we can take the moment generating function equal to expectation of e to the power of tx. So that means we can just simply we can say integration of minus infinity to infinity e to the power of tx fx dx. So here fx is the normal distribution function. After simplifying this, we can able to get the moment generating function as e to the power of mu t plus 1 by 2 sigma square t square. This is a moment generating function. Using this also we can extract the different type of moments also. First we can take the first moment is differentiation with respect to t of moment generating function of the normal distribution. After t equal to 0, we will get the mean value. At the same time, we simultaneously we will get the, if you take the double differentiation and t equal to 0, we will get the variance using a principle mu t equal to mu 2 prime minus mu 1 prime square. So that is sigma square. Next we can go for the mean and variance of normal distribution. So mean equal to expectation f x, that is equal to minus infinity to integration of minus infinity to infinity x of f x dx. So we will get the value is mu. At the same time, mu 2 prime equal to expectation of x square, and we will equal to integration of minus infinity to infinity x square f x, that is equal to mu 2 prime. After getting this mu 2 prime, we can able to get the mu 2 value, that is variance. So, and there are the standard deviation also there, that is equal to square root of the variance, that is sigma is standard deviation.
Yes. In general method is there, you can derive mean e of x square. Yes. Before that general method, already go for generating function. Is the one of the simplest method to derive the mean and variance.
Not only mean and variance, sir, we will get the higher order moments also using the moment generating function.
Yeah, exactly what Sampath sir said. A student can remember these important things. One is, so mean, and always a student can remember what is the normal distribution mean value, just now how to derive the mean and variance of the distribution. So just now sorry said explain about moment generating function. Making use of moment generating function also we generate mean and variance. Okay. So what is the mean here? Mean is generally we can represent it, mean is equal to mu and variance is equal to sigma square. A student can remember these two things because based on these two parameters this entire distribution will be described in detail.
Right. Now we can discuss the characteristic function of the normal distribution. The similar what we have calculated the moment generating function, similarly we can calculate the characteristic function of normal distribution using the principal expectation of e to the power of I t x, that is equal to integration of minus infinity to infinity e to the power of I t x f x to dx. Here f x is the normal distribution. Based on that we can generate the characteristic function as mu e to the power of I mu t plus minus 1 by 2 sigma square t square as the characteristic function of the normal distribution. On similar how we can calculate the moments of using moment generating function, on similar way we can able to calculate the moments from the characteristic function also.
Okay, sir. Okay, sir.
So simply sorry said that is a characteristic moment generating function as a characteristic equation. Both are similar, but only thing is instead of e to the power of it, e to the power of itx, then you write complementary value here.
Yes.
Yes, that is only difference.
What is the purpose of characteristic function? Already we have generative function is there.
Yes, yes.
Why you are go for characteristic functions?
So then means we have to check the skewness and curtices and their first order, higher order moments. We need to find out the higher order moments. We will get the accuracy results.
Yes. Sometimes maybe generative function not exist.
Not exist.
Then go for characteristic function.
That is will provide the exact solution, exact curve nature. Based on that our orders will decide the nature of the function. We'll check the data fitting natures.
Yes. Not only normal distribution, any distribution we can using this characteristic function we can able to find the different properties using this functions.
Yes.
At the same time beta 1 equal to 0 and beta 2 equal to 3, this is only for the normal distribution. For other distributions the values may be differ based on the characteristic function, and we can able to calculate the higher order moments. We can calculate this beta 1 equal to 0, beta 2 equal to 3. This represents the symmetry of the particular distribution. For particularly if we go for the normal distribution, the odd order moment should be 0. Because the symmetricity of the symmetricity character, the all odd order moments should be 0.
So all order moments means 0.
So Professor Raj sir, what is the meaning of beta 1 equals 0 and beta 2 equals 3?
So that means
the
beta 1
is 0.
Yes.
How to interpret it that students or understanding the
so
purpose
that means
of
the
beta
nature of the curve will identify if it is skewed. So origin to with reference to x axis how the curve is behave. So we should estimate if the beta 1 is equal to 0 and beta 2 is equal to 0, then only we will get bell shape.
So based on
then whenever the bell shape curve is there, the 99% of data will be considered in that any data statistical analysis. Okay. So that is one of the things. So that is one of the beauty of this normal distribution, because only one distribution is having beta is equal to 0, beta 1 is equal to 0, and another one is beta 2 is equal to 3. So no distribution, another distributions don't have this type of behaviors.
That is why normal distribution is a bell shaped curve or mesocurtic curve.
And we can say the father of the distributions, because this much of importance is there in the statistics. So we can say father
not only
of the
even though this psychology, in the psychology behavior of the student studies also based on this how. So whenever we conduct the exams, we distribute our question paper BTL levels to behave like a normal curve, probability curve. Then only that BTL level be satisfied. So nowadays we are NEP 2020 tells about outcome based education system. How we fitted this data, how your question paper will be designed. Based on that question paper numbers and BTL level, we can construct the normal curve. If you will get the normal curve, your question paper should be moderate and it will be satisfy the conditions of the normal distribution. Even though marked distributions also. That is the psychology. Then psychological point of view. Now,
what another properties of normal distribution? Please explain, Professor Sampath sir.
Next, we can discuss about the even order moments, sir. That is, we can say simply even order means 2n, mu of 2n equal to 1 into 3 into 5 into 2n plus 1 into sigma to the power of 2n. N is 0 to 1 to 3. So these even order moments also we can directly calculate when we know the standard deviation or variance values.
Yes.
Okay, directly we can get the higher order moments. At the same time, we already discussed that odd order moments are 0. And next we can go for the linear combination of independent normal variates. Is generally any independent normal variates, we can go for some differentiation. The following distribution should be the normal distribution only. Example, if x follows the normal distribution with mu 1 and sigma 1 square, and y follows the normal distribution with mu 2 and sigma 2 square, then x plus y follows the normal distribution of mu 1 plus mu 2 and sigma 1 square plus sigma 2 square. That means the sum of the normal variates should follow the normal distribution. So, even though if you take the linear combination of those things, it will follow the normal distribution only.
Yes, sir.
In a normal distribution also, we can able to calculate the quartile deviation, mean deviation and standard deviation also. So, this is a very important concept in normal distribution. We can able to define the ratio of these three components, that is quartile deviation and mean deviation and standard deviation. This should be range as 10:12:13.
Yes.
So, this is very important concept in normal distribution also.
Yes.
The mean deviation is 4 by 5 sigma.
4 by 5 is the standard deviation.
With its
QD is 2 by 3 sigma.
Yes.
Right.
Standard deviation is sigma. When the ratio you calculate, that is 10:12:15.
Yes,
Right,
exactly,
exactly.
exactly. Here quartile deviation, mean deviation and
the standard
deviation. These three parameters are vital, play the vital role in while calculating estimation of the parameters.
Next, the maximum ordinate lies at the mean value. That is actually where the curve, bell shaped curve maximum elevation is there. That is, we can say that is at the point of mu, that is mean. At the mean point, the ordinate will come, that is x equal to mu.
At x equal to mu, that value is 1 by root 2 pi sigma.
Yes,
That is why
exactly.
curve should be always maximum at occur at x equal to mu.
that is
only.
we can say single peak only.
Yes,
that
yes.
means
Single peak.
Yeah, that is unimodal curve
unimodal
we can
number.
say here.
Yes, sir.
If there are two tails, whatever extended infinitely and never touch the horizontal line, that is x axis line, the curve should not touch any time, because we have taken the minus into infinity x range, the curve will not touch the horizontal line. The mathematical equation is completely determined if mu and sigma are known only.
Yes,
Okay.
exactly.
And very important property for normal distribution is mean equal to median equal to mode in this particular distribution, because when we define the mode of this one, wherever the maximum value of fx, we can define that particular x value should be the mode. At the same time, the curve should be equally divided. We can say wherever the x value divides the curve into two equal parts, we can say that is mode. When these three calculations, when we look into the normal curve, these three characters are equal at x equal to mu only. So, that means mean equal to median equal to mode for particularly normal distribution.
Yes, sir. Yes, sir.
Yes,
Median
yes.
is divided
Yeah.
into two equal parts.
So that
given
is why
series.
Yes,
the
yes.
Mode is the maximum value of probability
Yes.
occurrence at x equal to mu.
X equal to mu.
X is equal to mu, then automatically the transfer standard normal variate is converted to z is equal to 0, which
This
is
is
divided
the
into
only
two
one
equal
distribution,
parts.
sir. Sir,
This
this
is
is
equal
only one
to-
distribution, only mean equal, median equal mode.
Yes,
That is called as a
exactly.
symmetrical distribution.
Yes,
So,
yes.
thank you very much, sir. So, once again, thank you, sir, for your valuable and informative lecture.
Okay.
So, now I go to another professor, Raju sir.
Yeah.
What are the applications of normal distribution?
Yeah.
The further, that is what area property is the most important. So, please briefly explain the area property of normal distribution.
Okay, sir. So, before that, just I will think about, say, just give the brief about once again what is a normal probability curve, okay, with diagrammatic representation also in upcoming slides. Okay, the total area under the normal curve is equal to unity. Just now we discussed.
Yes.
Okay, total area probability is 1 only, that is z is equal to 0 if it is divided into two parts. That is why total area must and should be equal to 1. And presenting percentage of distribution of area under the normal curve is given below. Okay, about 68% of area fall between mu minus sigma, mu plus or minus sigma limits.
We can say 1 sigma limits. We can
1
say
sigma
this.
limits and 2 sigma limits, and we have a 3 sigma limits.
Right.
So 68% of data falls under 1 sigma limits.
That is mu plus or minus 1 sigma.
Mu plus or minus sigma. And about the 95.5% of area falls between second sigma, 2 sigma
sigma
limits,
limits,
that is mu plus or minus 2
sigma,
sigma. About 99%, 99.7% of area falls between
3 sigma.
3 sigma limits, that is mu plus or minus 3 sigma.
Yes, for that purpose only, in general, we can use 6 sigma limits in quality control
Yes.
also.
SQC,
So
quality
now-
controlling.
Yes,
we will
yes.
get the 99.7 accuracy of whatever we test in quality control. In
yeah.
that, we are using the 6 sigma limits.
Yeah, whatever the things just now we discussed, just I have shown this picture, this is a bell shaped curve. So this is called as a percentage of distribution area under the normal curve. What I said, this is 68.27% up to this is a 1 sigma limit. Now if I take the 90, so up to this point 2 sigma limits. Now if I take the entire data, this is 99.73%. This is the 3 sigma limits. I represent here mu minus sigma up to this part, and so now I said just this normal distribution is never touch our x axis. I will see in this curve last horizontal curve.
horizontal
So
line.
this is x axis. This tails, this left tail and right tail never touch with our x axis.
X-axis, right.
Yes.
Okay, so our range of the distribution is minus infinity to here minus infinity this side is plus infinity. We will get the maximum value. Where we get the maximum value here? Ordinate. This x is equal to mu. That is why this normal distribution behave symmetrical about mean, median, mode. Okay, so this is the curve. So total explanation depends on this curve. If you understand this curve, we can able to answer any type of questions given to in examination point of view also. Now, so uses of what is the use of normal distribution in general?
Yes, sir.
Okay, what Sampath Sari said in the beginning also, few already we are using the sampling distribution and other things, but in that normal distribution can be used approximate to the binomial and Poisson distribution, because these two are the limiting case of the normal. Binomial distribution is a limiting case of normal distribution, as well as Poisson distribution is also limiting case of normal distribution. These are the two important approximations. Okay, so it has extensive use in sampling theory. What already one of the my professor is Sampath Sari said already, what is the use of sampling theory? Okay, so sigma limits. So sigma limits,
Quality
quality
control.
control point of view, use this normal distribution concept. Okay, next one is it helps to estimate parameter from statistic and find the confidence limits of the parameter. So this is plays a vital role in the testing of hypothesis. Okay, so how to estimate the parameter? If you know the parameter and statistics, then only we should identify the confidence limits, level of
Confidence limits and data properties.
data
and everything.
properties and other things.
Yes, yes.
Okay, it has a wide using in testing statistical hypothesis.
Yes.
Yeah, and test of significance, in which it is always assumed that population from which the sample have
Drawn
have
from
been
normal
drawn
population
from
only.
should
Normal
normal
population
distribution or normal population.
Yes, sir.
So why normal population? So its data is sync with our normal distribution. That is why we are always consider this normal distribution. It has a significant applications in statistical quality control, as the control chart in statistical quality control is closely related to normal distribution. This is one of the important accept. Okay, now it serves as a guiding instrument in analysis and interpretation of any statistical data.
Example here is a regression analysis.
Yes,
Without normal property of the given data, we cannot go for the regression analysis. We may not get the proper results.
Yes,
Because first we are supposed to check the data follows the normal distribution, then only we can go for the regression analysis. This is one of the important tool in statistics. Without a normal property, we cannot do this regression also.
Yes, exactly, sir. So just that is a modeling, forecasting modeling.
Yes,
So if
forecasting
you have to
modeling.
go for forecasting model, this normal distribution play the vital role.
Very important.
Yes.
Very important role, key role. Otherwise, we can't forecasting the nowadays. Many of the organization, they are forecasting the things, how the behave, what is the current trend, how the future. So estimation, this based on this normal properties. That is why this normal distribution play the vital role in the trend analysis or statistical analysis.
Yeah. Wherever we can apply the parametric analysis, anything in statistics, compulsory that data should follow the normal distribution.
Yes, sir, exactly, exactly.
Right.
So after that, we will go for one more important topic is that is fitting of normal distribution. Fitting a normal distribution or a normal curve. Okay. So, normal curve is play the vital role because we need to study the nature of the curve. The purpose of fitting of the normal curve is twofold: to judge whether the normal curve is a good fit to the sample data. Another one is to use the smoothened normal curve instead of the regular curve representing the sample data is to estimate the characteristics of the population. Generally, we use the diagrammatic representation. Sometimes it is not effective to not get the correct idea about the distribution. In that case, we can go for this fitting model. Okay, fitting of a normal distribution case. Now, there are two methods finding the normal distributions. One is ordinate method, second one is area methods. So, ordinate method, the normal curve can be fitted by reference to a table of ordinates of the probability curve. Then coming to second method is area method. The normal curve can be fitted by reference to table of area of the probability curve. So, the total already we discussed total area of the probability is 1 only. So, the total area under the normal curve is always 1. Okay. So, now how to find? So, what is a working procedure? A student can understand how to find the probability when the variates normally distributed. So, for that a student can understand, a student is able to understand this procedure. That is why I am going to explain step by step procedure.
So, these are very important for examination also.
Yeah, what Dr. Ramesh said is a very important point of view. Examination point of view also, working procedure is a student is understanding the working procedure, then he is able to apply these methods wherever it is applicable. Okay.
This is also very important in competitive examinations also, these methods. Most of the even general knowledge quantitative techniques questions also, some of the competitive exams also these type of questions are asking. So, this is very important topic for graduate students for learning how to calculate the probability values with the range.
Yes, sir. With now I am going to explain for student point of view, for a student understanding this concept. For that I am explaining the working procedure and few example problems for understanding of the student. Okay. So